Good morning, geometry. Welcome back to another class. Today we get to start chapter 18. You'll like this chapter. This chapter is relatively easy. So what we're going to look at in section chapter 18 is, and specifically section 1, we're going to look at volume of prisms and volume of cylinders. And we're going to look at two different types of prisms, and we're going to look at two different types of cylinders. We're going to look at right prisms, and we're going to look at right cylinders, and then we're going to also look at them as oblique. Okay, so it's not a very difficult section. It's going to require us to know which formula to use at what time, but here is what the essential question is dealing with in this section. How do the volumes of formula of a prism and a cylinder relate to the area formulas, which we already know? Again, you're very familiar with the area formulas. You've been doing it probably since 4th grade. We know the area of a rectangle is length times width. We know the area of a square is also length times width, or it's just the same side squared. You also know the area of a circle, which is pi r squared. So again, those are things, those are formulas that you're very familiar with, so we don't have to really talk about it. So what I want to do is just do some examples. So now again, in your HT&Cs, you'll run across 3 pages that deal with topics on area, not only just area like length times width, but also surface area. That's another important thing we'll look at later on in chapter 18. And then volume of different type of geometric shapes. So HT&Cs, page 1, 2, and 3, you'll see a wide variety of geometric shapes and how to find the area, volume, surface area, all that other stuff related to prisms. Now, what I want to do is go right into how easy this section is. Again, like I said, how is the volume of a prism or cylinder related to area? It's very similar. Again, here in the setup, we know we can figure out the area of this right prism. That's like a brick or a box of Kleenexes. It doesn't matter. It's a rectangular shape. It's nothing more than taking the area of the base, okay, times the height. And again, the area of the base is this part right here. That's the length times width. And we can relate it to the volume of a right prism. Length times width times height. And remember, the length times width really is the area of the base of a right prism. Same thing over here on the cylinder. This is just like a coffee cup, a can of soda, or we say in the north, a can of pop. Once again, area, volume is nothing more than the area of the base times the height of that can or height of that cylinder. And area of a circle is nothing more than pi r squared h. Now, while I'm at it, again, we are going to use the pi feature on our calculator. Again, over here, that's what we're going to use. Back in the elementary days, you probably rounded pi to 3.14. What we're going to do is we're going to treat it as a true pi. All right? So the only way to do this is by just get us introduced to some examples. So again, if you take your textbook and if you open up to open up to the next part. Again, I didn't do any on this because it is really relatively easy. Now, when we get into oblique prisms and oblique cylinders, again, the only difference between these two is they're just askewed. They're just tilted. It still has the same common features of a rectangular prism. Like a rectangular prism still has a base that's a rectangle. An oblique cylinder, it still has a base of a circle. So again, the only difference is instead of it being like again, going back to the picture, instead of being in a vertical setup, it's been tilted and nothing changes. So again, here, the volume of an oblique prism is nothing more than base times height. And once again, you already know what the base is. The base is the area of a square or an area of a rectangle. So volume will equal length times width times height. Concept is still there. Over here, the volume of oblique triangle is the area of the base, which is the area of a circle. That's pi r squared times its height. And once again, if you see it, I'm leaving it in terms of pi. So what I'll do is, again, take your books and look at page 629, and we'll go right at the bottom of the your turn. I'm not really interested in those pictures, the way the problems are set at the top. I'll talk them through. So your terms, we want to find this oblique cylinder and this oblique prism. So what I like you to do is, go ahead and pause the video, try to work these out, and then unpause it. Check out on your solution sheet the your turn answers and come on back. Okay. All right. So I'm going to do both of these at the same time. Ready? So the first things first is in number 6, we're dealing with the volume of an oblique cylinder. Once again, it's pi r squared, which is the area of the circle, times its height. And again, this is your height. And this problem, number 6, they gave it to us. So this was already given. There's our given information. You can follow that. Over here on number 7, I wrote it as, talked about it a moment ago, in terms of area. So it's the volume of a oblique prism is the area of the base times its height. And if you look at this problem, they gave us our length of 4x and our width as 5x, and our height is x plus 2. So all we got to do is just apply those two rules based upon what's been given. So again, we'll do both of these at the same time. So if I go over here to the oblique cylinder, pi times the radius, but we already know our radius is 12, so it's 12 squared times its height, which is 45. Go over here to the oblique prism. Our base, once again, is the length, which is 4x, times its height, which is 5x, multiplied by the height, again, length times width, the height, which is x plus 2. And after this, especially with number 6, it's just calculator work, okay? I'll show you. To figure out what pi is, you do the second button and the shift button. Multiply that times 12 squared. Multiply that times 45. And you get 20,357.5204. Now again, for homework purposes, you can either leave your answer as to the nearest tenth or to the nearest hundredth. It does not matter which one you want it to, but I left it as perfect tenth. The oblique prism is algebra work. 4x times 5x is 20x squared. Power times a power, bases are the same, you add your variable. So again, here on the left, our oblique cylinder, I round it to the nearest tenth. And please remember something. Now that we're getting into area and volume, we have to have our unit a part of all our answers. So be very careful in dealing with that. We've got to see the unit in there. I may do something tricky on the tests by not putting the unit there, even though you may have the same answer here, but I'm going to make sure that you know that unit in geometry is really important, especially for those of you that are going to be going to taking physics in the future. Units are important. All right, so the first one is 20,357.5. Again, this means cubic inches. There's the cube sign, cubic inches. And this one over here, Bob may have this, okay? This one is cubic centimeters. And what I just did here in this example is I just multiplied the length times width. Again, get 20x squared. Again, forgetting, now remember x squared comes from the x times x. Power times a power, they have the same base, you add your exponents. Now, you can also take this oblique prism, and you're more than welcome to write it this way by applying distributivity. So you got a choice here. But I think Bob is going to have it this way. All right? Like I said, this is not a difficult section. Now, one more thing we got to get into before we finish it up is dealing with finding the volume of a composite figure. In other words, it's a figure composed with more than one geometric shape. Okay? And what I have done is I went down and we did letter B. Now, letter B is just an example of a picture of a periscope, which is made up of two congruent cylinders. Here's one cylinder, here's another cylinder. Again, going back to congruency, that means they have the same length, they have the same diameter. So that all that stuff, when it comes here, congruent means they're the same. And we also have two congruent triangular prisms. So these two are congruent. That means they have the same length, the same width, and same height. All right, so now some other information you got to be careful with in word problems is you got to highlight stuff so you can get an idea. So again, the height of each cylinder is 6 times the length of the radius. So that's added information to this. So using the measurements provided, again, they gave us the area of the two bases of our cylinders to be 36 pi square inches. Use these measurements provided to estimate the volume of this composite figure rounded to the nearest tenth. Now, it's composite. It's composed of 1, 2, 3, 4 different geometric shapes. And we want to find the total volume of this figure. All right, so the first part they look at is dealing with the area of your cylinders. So the area of the base, we know is the base is pi r squared, which we already know is 36 pi square inches. Okay, so pi r squared is, again, in this case, they went back here in order for us to do it. They want us to find the radius. So to find the radius of this guy, of this shape right here, we just use a little bit of algebra on this part. So radius is nothing more than the square root of its base, area of its base divided by pi, and we got it to be 6 inches. And we want to calculate the height of each cylinder. Again, this all ties into concepts of the formulas and algebra. Okay, the next part deals with the triangular prism. Again, what they've let us know up here earlier, let's see, where did I see that? Okay, let's see. Well, okay, I had it in my head and it had gone away from me. The faces of the triangular prism that intersect the cylinders are congruent squares. So the side lengths S of each square is the same as the diameter of the circle. You can see that right here. So that means each side is going to be a length of 12 inches. Again, here is the two triangular prisms form a cube. Again, we know that because they're since they're the same geometric shape. And if you were to put them together, it would be a cube. So they show us the volume here of the cube. Okay, then the next part they did is they found the volume of the two cylinders. We found the volume of our two triangular prisms. And with that said and done, again, all we got to do now is add together the volume of our two cylinders. So here, this is the volume of the two cylinders. This is the volume of the two prisms. And again, here, this little symbol right here, that means approximate. So all they did in this case is they took our answer using our calculator, add these up, round to the nearest tenth. So again, this composite figure has 9,871 cubic inches, and that will be our answer. And again, it has the unit ascribed to it. So again, this is what section 18-1 is all about. How to find, or how do the formulas for volume of a prism or a cylinder relate to the area formulas. Again, I don't think you're going to have any problem with this section. I think the big part that you may have difficulty with will be when you get into different types of composite figures. You got to pick it apart. Okay. Again, if this is a little bit too complicated for you guys, just a little bit too much for you to do, here's another option. Okay. So ignore all this stuff right here. Again, find out what the volume. Again, in this case, the directions already told us that these two shapes are congruent. These two shapes are congruent. And if we just take one of the shapes, find its volume, and double it, that will take care of these two volumes of those two figures. Again, find the volume of one of these prisms, and double it, you get the second one, so you can pick it apart. Okay, that's another way of doing it. So it's really not that difficult. Remember now, we're using a pi is not going to be 3.14. We're going to use the pi feature on our calculator. So I think that will get you guys started on chapter 18, section 1. All right, next video will be on section 18-2. All right, guys, catch you later.